Welcome to the channel. I know you've seen multiple videos about Desmos, but if you want to use Desmos to answer hard Model 2 questions for your incoming SAT, stick around. 5 questions, hard Model 2. I'm going to show you strategy, how to regress properly, how to read through the question, come out with the better input to get a good output. At the end of this video, you will never regret sticking around. 5 questions. Grab a pen and paper. Let's go. First question, as you can see, is exponential function question. It looks intimidating, but we got you. This is the function, can be rewritten in this form, where n is a positive even integer. And n, if n is as small as possible, which of the following is closest to r? Look, when you read a question, don't just jump and start to solve it. There's something in the question that will give you information. I say answering a question 50% of the time is in the question before you do anything. So 50% is analyzing the question. And what is that? Positive even integer is key. And then the smallest possible number. Now, you can see that this exponential function, the constants are the same, but the basis has changed. Exponents are not the same. They're telling you they're the same. Therefore, define the function to Desmos. That's what we're going to do. Input the information in Desmos, and then regress the individual function, and you can get one equation based on what they've given us. So we have 4x as exponent. Now, h of s has a bunch of constant. Desmos will not be able to plot it as he plot the first one. We have 1 r over 100 because the equation is being written, but it's the same thing. Now, minus nx. We don't see that graph. Okay, let's regress the other function because it's the same thing. And telling Desmos, I want you to turn that into that. Now, we have this function. So you can see this is the function it's plot. The h of s is green. It doesn't match with the g of x. Why? Because x is 0, right? We got to pick our random number. So we pick random numbers of 10. And now the two equations are the same. If I take one of them out, if I take both of them, you can see blue back, green. If I take blue, green is there. I bring a blue and that. So they are all the same function now. Now, what are your answer? R is 14.6, N is 14.6. But there's something in the question telling you. It said N has to be a positive integer. This is not a positive integer. And then n has to be the smallest of all the possible integers available. Okay, well, I'm picking n. What is the smallest? 0 is not, right? I'm going to pick 1. 1, I get r is 90. Is this the smallest possible integer to give you the closest value of r? Well, look at r. N is 1, right? Pay attention. N is a positive even integer, not an odd integer. 1 is a trap. You pick n is equal to 1, you get r is 90, you pick 90. The question says even integer, therefore 2. And 2 give you 68.64. If you pick 4, you get 44. 44 is not the smallest positive even integer. We're picking n to be the small as much as possible. Pay attention to the question and you get your right answer. This is a trappy SAT question. An integer, we can pick 6. We get r to be 32. It looks smaller, you pick a, right? But look, we are not dealing with that first. The smallest number we're picking is the n. The n1 is not an even, n is 2 is an even, that's the smallest, but your number of r is 68.64. So C is our right answer. Question 2, you've been given this function, and it said A, B, C are constant. This graph, f of s, as a vertical asymptote at s is equal to what? 5. There's also an s-intercept, 2, 0. This graph in this form, top one, opens downward, and f of s is greater than what? F of 0 is greater than or equal to 0. What is the greatest possible value of BA. This question is all algebra, conceptual. It's actually easy with algebra, but I know 99% of students, when they see it, they want to grab Desmos. So I'm going to show you how to use Desmos. But most of the things I will say is all algebraic information. And if you know it, it becomes easy. What is the first thing? I will define the function for Desmos. So we have AS squared BS plus C. Then you bring your denominator 2x plus D. Now, the first thing I'm going to say, I'm going to create my own graph based on the information they've given me in algebra. So I'm going to label it G of X. The algebra, I know. They said the root is what? Intercept 2, 0 means that's a root. So X minus 2 is the first root. There's a second root, which is f of x. There's a second root, which is f of 0 is greater than 0, right? Or equal to 0, but we don't know. So I'm going to assume that this is k. That's the second root. And then we told that the graph is going to open what? Downward. That means our a here is negative. You see what I'm doing? I'm creating a new function using all the algebra. The third thing they told us is we have a vertical asymptote at what? 5. That means 2 times 5 plus D should be equal to 0. D has to be what? Negative 10 when you solve it. Therefore, my new function, I'm telling Desmos, I don't want you to guess too much. Make this minus 10. F of S is the same as G of X, but I've made this function so simple for Desmos that it will be easy for Desmos to figure it out. Well, let me take what? A slider, you see, and he plotted for me. He plotted a graph like this for me. 2 graphs for me. This is a classic example of what it would look like if you plot it, right? And I'll show you some elegant information, things they will teach you in class that you don't see, right? Now, we are told that G of X, which is G of 0, is greater than or equal to what? 0. You got to define it. Now, I'm telling a bunch of things to Desmos now. Okay? And we are told we have a vertical asymptote. That means the graph would never cross that at s equal to 5. And that's the blue line. And this is, you can see exactly s is equal to 5. If I show you the graph from the top, it's a very nice graph. You see, it never crosses. It gets closer and closer and closer, but it never crosses that graph, that X line. And I'll show you something. Now, I have enough information to tell Desmos to regress the two function, original function, so that they can calculate what is A, B, and C. And this is what he did for me. He said A is minus 2, B is 1, D, I don't know, but he gave me X is 1. Therefore, I need to like make sure we have all possible of X. So I can take a random number of X like that. And boom, he said A is what? Negative 1, C is negative 2, B is 3, and D is minus 10. We get our D. We already know D is minus 10 from that function. So I know we're getting somewhere. And we have a function that is consistent with that. Now, what do you think we should do? What do you think we should do? Everything depends on the second root. If you look at the second root, it said f of x is, which is f of 0, is greater than or equal to 0. If you put 0 here, here, and here, and here, you'll be left with what? F of 0 is going to be c over minus 10. And this is what? Greater than equal to 0. And this is the key. So we're going to use that information to answer that question. So the lowest number that we're going to have is k is equal to 0. That's our boundary. So move your k. I hear k is what? 1. It said is what? K is like the function we're trying to find. You can start from 0, 1. It says equal to 0, and above. Therefore, I'm going to put 0 here, and this is the graph. I'm going to move 0, k, until I get something. And before that, look at what our answer choice is what? B over A. Like I said, this is mostly algebra. You see it much better with algebra. So based on this value they've given me, I'm going to move this up here so that you can see. Based on the value given me, he said B over A is -2. Is that the greatest possible value of B over A? I don't know. I'm going to move K, and K is going to change the function. As I move K, let me put a step there. I would say step what? 1. So I'm making something integer, right? So that it will be easy. Now, if I move 2, look at B. It's getting bigger. B over A is getting bigger. When I move K is 3, B over A is -5. I make K is 4, B over A is -6. What is the trap in this question? If you don't pay attention and you don't know this trick, you will fail this question because Desmos give you numbers, but if you don't know the algebra, you can't. I want you to pay attention, master your algebra. Look at B. B is increasing, right? B keep on going up if I go up on K. But what is happening to A? A still remain the same, no matter the number of A, because it's a negative number. If you divide that function, it's going to be a negative number. So the bigger the negative number, the smaller it is. That is the key this question is testing. If I make this 5, B is 7. But what? B over A is -7. Is what? Is this the smallest or the biggest? It's the smallest because our first number we got was -2. And therefore, I know I got to come back. And I'll show you something happening to the graph. So we start with 0. I'm taking time teaching you this because it's very important. If you understand this and you're doing regressions, it becomes easy. You look at the graph, you can figure it out. At 0, we see we have the solutions, right? And this is the solution. Look at the graph. S is 0 and S is 2. Consistent with that. That's the K. I told you the K is 0. This question, I can teach you so many things. S is 0. That's the root, K. So when I say K, I'm just changing the root, different kind of root to give me the highest value of B over A. If I make this 1, you see B over A is -3, smaller. I make these 2 smaller, but look at the graph. They coming closer to each other, Look at 5. Boom, it's gone. Why? This is what we call a hole. Whenever you have a vertical asymptote, this is 5. The graph was here and here. They're supposed to stay away. They shouldn't cross. But when the value of K is equivalent to the asymptote, it becomes a straight line. How? Look at this function. If I put S is equal to 5 and S is equal to 5, you basically have a linear function. It becomes a linear function because this becomes X minus 5. And here you have 2x minus 5. And they cancel each other. And you have negative x minus 2 over 2, a linear function. That's why you have a straight line. And this creates a hole in the graph. If I go up 6, it will come back. Boom. That's why they don't cross. It's called a vertical asymptote, a key demonstration of that. And this question demonstrated. So the right answer is when K is equal to 0. That means this root is 0 and B over A is -2. So the greatest possible value is -2. The data set is 3, 5, 9, and 10. 3 positive integers are added. This led to what? 9 values, mean of 9, median of 9. What is the least possible range? If you want to learn how to solve this kind of question, check my channel. If this video is helping you so far, subscribe for more content like that and put a little bit of comment. But this is hard model 2 questions. If you can solve it, most frequency questions will be easy. I'm going to show you the algebra to answer them using Desmos. It requires some thinking, so I will be talking through it. First, you need to define Desmos and tell them, hey, I have a number, so M is my list of numbers, 3, 5, 9, and 10. And it's saying what? We had 3 even positive integers. I don't know the numbers, but I can say that S1 is the first number. I will label it at 1. S2, I said I would label it also 1. But S3, I got to figure out what it is. You got to help me. How do I figure it out? When you know your definition of mean, it means you have 3 numbers divided by, sum it, divided by a certain number will give you mean. That means 7 numbers multiplied by 9 will give you the mean. Therefore, the sum of all the numbers, okay, right? We don't know. But if I multiply the mean and the number of numbers, will give you 63. Therefore, if I sum all of them, we'll do that. But I only have what? 4 of them. So I'm going to sum the 4, which is what? Think about it. That's all I'm doing. I get 27. That means the 3 numbers I'm going to bring is what? 63 minus 27. Therefore, they should sum up to be what? 36. But what is the problem? They are even numbers. So they are 2 times of S. These S's are 2 times. Therefore, if I sum X1, S2, S3, it will be half of this. Therefore, this should be what? 18. And therefore, I will say 18 minus X1 minus X2 should give me X3. And you see, calculate for 16 for me. And that is consistent with what you had. So I'm going to take these off because I don't need them. I'm showing you how to use Desmos to think through this kind of question. All right. Now, what is the next step? I got to put some restriction because in order to get the median of 9, look at the numbers 3, 5, 9, and 10. There's already 2. This is the algebra that you don't see with Desmos. You think through it. Once again, Desmos does not solve questions. It's you who solve the question. You input the information in Desmos, and then you get a good answer. So learn your algebra, how to manipulate the numbers. If you don't know, you can. This question, I look at it and say, what? In order for 9 to be in the middle, and I need 7 numbers, well, I already have 2 below 9. I just need 1 number below 9. Therefore, the smallest number is going to be 1. Therefore, this is what I'm going to say. I'm going to say that what? X1 is the smallest, right? And it should be less than or equal to S2. And S3 should be the largest. So S2 is less than or equal to S3. And now I'm telling Desmos, this is the thing I want you to do. Now I have my new functions list 3, 5, 9, 10, and I know what is that. This is the key to, because they are twice the numbers, you got to put 2x1, 2x2, and then 2x3. Now, you see all of a sudden it picked the numbers for me. I say, hey, sort the numbers for me so that I can see it better. So Desmos sort it for me, sort n for me. And he sorted for me. So I'm going to put it here so that you can see what is going to happen. I'm going to move these numbers so that 9 can come in the middle. That's all. Sort it for me. He sort them in the order that it's supposed to be, right? But is this the number that we want? We got to change these numbers to bring 9 in the middle. So I know I got to keep, this is another algebra. If they ask you for the largest possible range, make one of the numbers the smallest as much as possible. If you can make it 0, 0, but you can make a positive even integer 0. And then you make 1 the largest. So I'm going to keep x1 as 1, right? And then just going to change what? S2, because I know S3 is going to be the largest and it's going to stay like that. So I'm going to change it. I'm looking at what is happening to 9. If 9 come in the middle, I like it. So I'm moving and you see, or you can say that's another clue. I'm going to say step 1 because, or you can say, yes, step 1 so that it doesn't bring in non-integers, right? So I can change it. Next one, 3, right? 9 is still not there. Now you get something. 9 is in the middle. But what numbers you have? What do we have? We have added what? 2, we have added 10, and we have added what? 24. So look at those numbers. 2, 10, 24, right? Let's see if this is the another number that can get you the same thing. I put 6 here. I have 10, 12, and what? 22. But what do I add to it? Look at it. The mean never change. 9 is in the middle. What has happened? We had 2 and what? 12 and 22. 2, 12, and 22. And this is where most students will mix this point. Always, like I said, Desmos is a good thing, but always try it. Pretend you don't know what he's saying and keep on looking for numbers. Don't jump the gun. So here we have 2. 2 was added, 12 is being added, and 22, right? When we bring S to 5, S2 to 5, what numbers were added? Look at it. This is where you can mix it. Now, in this number, we have 2 still, but we have 10 and we have 24. So 2, 10, 24, right? These are even integers. You can see this is much, much better. We're maximizing this. Can I go up? Well, let's make this 4. We have 26, 10. Somebody will say, oh, I get it. No, you don't. Look at it carefully. I have 26, 10, and 2. Okay, we make the one of the number bigger, but look at 9. 9 is not the median anymore. Therefore, you know that you can't go anything lower than x2 is going to be 5. And 9 is in the middle. I have 10, 24, and 2. This has a better range than this, because when you subtract this, you get 20. Wrong answer. 2 from 24 is 22. Better answer, right? Because I have my median, 9. I have mean, which I fix it. I fix it from the beginning. And you see, calculated for me, 9. I can tell that based on the numbers it's giving me. We already calculate. We already fix it with this. Therefore, you see the mean just pop up. Maybe I did not show you in the beginning, but this is it. And therefore, for this to be in the middle, this is the way it's going to look like. This is how you solve it. And therefore, your right answer is 22, not the first one. And 4 is another exponential function. We're going to use the same concept. We have 2 functions, and they said these numbers are all constant, where r is greater than 1 and k is greater than r. When you graph those 2 functions, they said the minimum value, which of these is displayed as a coefficient or a constant. This is another quick algebra question. Just by looking at it, you can pick the answer. Some people like Desmos. How do you use Desmos to solve it? This is the way. Just input the function, and I'll input the second function. And look at what it's telling you. What are you going to do? Let's pick some slider. I pick a slider and it plots the graph for me, right? I'm going to restrict the graph so that otherwise it's going to go into infinity. They say something here, x is greater than or equal to 0. I'm going to put it there. X is greater than or equal to 0. That's a key restriction to put on the graph, and it will cut it off. You see, it cut the red off. Always use that restriction. Otherwise, you go into infinity. And now, these are our 2 functions. Another restriction we got to put here is say what? R is greater than 1. Here, R is 1. I'm going to put R2. K is greater than R, where if R is 2, K has to be 3. And this is the values given up. Now, they say which of them is displaying the minimum value as a coefficient and constant. Well, what is the minimum value of the red? The red is here. It's 2. The red is the what? The first one. The minimum value is 2. What is 2? It's an R. R, do you see it in the function? Boom, it's right here. It's being displayed. What is the minimum value of the blue one? Well, it's 7 point something, 7.089. What is the function? I don't see 7.089 there. You have to calculate it to get a minimum value, right? And therefore, based on that, the only thing that is being displayed as a constant and a coefficient is only 1. And you can see how the graph get plotted, and you can see it. But you can also solve it algebraically just by looking at it. You can see because of the constant, it cannot be possible. But it may be possible depending on the normal values they give you. But the graph also help you, Desmos. You can see the minimum value are being plotted, and we put our restriction, and we can see it better. Otherwise, you won't see if you don't put those restrictions there. 5. You've been given this equation. They say P and K are positive integers. There is no resolution. If the least possible integer value of P is 6, what is the value of K? Well, this looks like a quadratic equation. Just define it in Desmos and let Desmos go to work. So I'm going to put the equation as given. And now I'll pick a slider. And I have two solutions right away. Now, I know they said what? There's a restriction there. P has to be the least possible integer, which is what? 6. I change this to 6. I still have my two solutions. The only thing that is preventing me getting the answer is K. I got to make K the least possible value consistent with the P is equal to that. And therefore, I'm going to make this go up. And you can see the graph coming together. And then when I get to 4.1, 4.2, 4.1, there's still something there, two solutions. 4.2, it vanished. And if I go, I don't get it back. I keep on coming back again. And 4.1 is there, 4.2 is gone. Therefore, K is 4.2. But that's not an integer. The least possible one, it has to be what? 5. If I put 4, it's right. There is a 2 solution. If I put 5, it's gone. Therefore, the least possible value of K that is needed to be an integer is 5. Think about it. These can change. You can change P numbers. Some people will say, hey, okay, well, what about making P close to 7? It's an integer, right? Well, P, the K value is going to change, right? It's 3.2, right? When does it go away? 3.7. So your answer choice should be 4. No, it's wrong answer. The question is least possible value of P. P is controlling everything. Therefore, least possible value of P is 6. You've been given to you. If you go 5, well, 5 is less than that. And then you can see that the solution, the K value is what? 5 after 5, then it vanished, right? So 5.1, there's no solution. So it has to be 6. And therefore, this is a wrong answer. We want P to be 6, and our K is 4.2. And therefore, K is 5. 5 questions. I know you learned something. How to use Desmos, how to manipulate numbers, how to think about a question. If video help you, subscribe for more content like that.